Today we're going to talk about the MapSync GPS to GIS Toolbar, working with PFO tools in ArcGIS. So before we begin, why is there a need for GPS to GIS tools and workflow? Because cities, counties, and states are being required to report, inventory, and maintain data on their addresses, utility facilities, and other assets within their service area. Users, and most likely these are utility technicians, city clerks, 911 and EM personnel, need tools that fit easily into their daily workflow. These tools can help with better, quick, informed, and efficient decision making. The MapSync GPS to GIS Toolbar is located within ESRI's ArcGIS software in the ArcMap platform. It's a customized toolbar created to meet the needs of MapSync and CDP customers in moving their utility, planning, 911, emergency management, and various data types from field data collection to office analysis and use. The GPS to GIS Toolbar hosts a group of add-in tools that includes 5 Trimble PathFinder Office tools that work in conjunction with TerraSync on the GPS unit. The MapSync Append tool, also on this toolbar, will be discussed in a separate webinar. The MapSync GPS to GIS Toolbar is highlighted in yellow, and you can see this in the ArcMap platform of the ArcGIS software. And if we look closer at this toolbar, we see the PathFinder Office Data Transfer Utility Tool. We see the PathFinder Office Data Dictionary Editor Tool, the Differential Correction Tool, the Export to GIS Data Tool. This is the MapSync Append tool. And we have another PFO, the Settings tool. And then we have the Go Account Sign-In tool. This is the MapSync GPS to GIS Toolbar. So if we talk about the workflow steps in the GPS to GIS process, we can narrow them down to these six steps. 1, create a data dictionary for GPS unit using the data dictionary editor. The second step, we would transfer the data dictionary file that was created to the GPS unit using the data transfer utility. Then you go out and collect your GPS data in the field. The fourth step is to transfer the GPS data to the computer using the data transfer utility. The fifth step is to correct that data using the Differential Correction tool. And finally, the sixth step is to export the GPS data to GIS format using the Export to GIS tool. This is the data dictionary editor. This is a sample sewer data dictionary file. On the left window, you can see the features that were created for this data dictionary. Manholes, pump stations, meters, you can see them there in the left window. To create a new feature, you would simply press the New Feature button down at the bottom. Now, if you see that Cleanouts is highlighted, you can see over in the right window the attributes that have been created to be associated with the cleanout. So if you're out in the field using the GPS unit, these are the attributes that you would fill in for the cleanouts. You can see an ID, size, material, and comments. These were created using the New Attribute button down at the bottom. Also, you can see, as we've highlighted material, if you look over on the far right, you can see the menu items that have been created for the material values. These are in the drop-down as you're entering the data for this in the GPS. You can see a sample of a water data dictionary. Again, you can see the features that were created on the left, and then the attributes that are associated with the size for the water valve on the right. And then you can see that also size was created as a menu item. And so you can see the sizes that were entered as values in that drop-down option. So if we use the Data Dictionary Editor and we press the New Feature button, these are the forms that pop up so that we can create the new features. So we would add the new feature name, for example, hydrants. We would select the classification, point, line, or area, and then you can choose the Symbol tab if you would like to select a color and symbol for that feature. When you're ready to create a new attribute for that feature, like hydrants, then we would select the New Attribute button. That will open the new attribute type form, where you can then choose menu, numeric, a text, a date. And so if we choose a menu, we see the new menu attribute form open. And you can see size has been entered here. And these are the values that are being entered for size, 2, 3, and 4. And then you can see the new attribute value form where you enter those values. And you can see that 6 is about to be added. So you would repeat this process for all of the features and all of the attributes that you want to be added to your data dictionary file. When you're done, save and close the data dictionary. So the next step in the process would be to send that data dictionary file to the GPS unit using the data transfer utility. So with the GPS unit plugged in and connected using the Windows Mobile Device Center, the data dictionary file can be transferred to the GPS unit. In this case, you would select the Send tab to send that file to the GPS unit. Then you would choose the Add drop-down option and select Data Dictionary. Use the File browser to select and open that data dictionary. And once the data dictionary is listed in the files to send, you can select and transfer all to the GPS unit. Now you're ready for field data collection. But before you leave the office, you should go ahead and check your GPS unit and make sure all of the settings are as they should be. Check the logging settings, the accuracy requirements, check your coordinate system and units, and make sure all of that is consistent with your ArcGIS project. When you're in the field, but prior to your GPS data collection, make sure you update the almanac on the GPS unit. This gets a fresh timestamp and location for the GPS. Also, be sure you review the satellite positions and receiver information so you can keep in mind where the satellites are while you're collecting your GPS data. For other helpful tips while you're collecting your data, start a new data file each day. Never open an existing file from the previous day and start using that. If you take a lunch break, be sure you turn off your GPS unit to save battery life through the day. While you're collecting your data, keep the antenna uncovered and unblocked. Hold the GPS unit level while you're traversing, or even mount it to a pole for continuous satellite lock and antenna availability. When you're done for the day, be sure to close the file and exit TerraSync. So now you've collected your data, and let's say you go into the office the next morning and you're ready to go ahead and process this data. With the GPS unit plugged in and connected with the Windows Mobile Device Center, the GPS data can be received from the GPS unit to the computer. So select the Receive tab. This is actually the default, so when you open Data Transfer Utility, the Receive tab is always selected first. Press the Add button to choose the data file. Use the File browser to select and open the SSF from the previous day. Once that's been added to your Files to Receive list box, then select and transfer all to move the data from the GPS to the computer. Now it's time for differential correction. So differential correction is the process of removing error, man-made and natural, that distorts the GPS measurements. You derive coordinates from a known frame of reference, or the base station. These are CORS stations, continually operated reference stations. And you take the raw GPS file, or the SSF, and adjust the feature positions using these base stations to create a corrected file, or a .cor file. So you open the differential correction tool. You're going to use the file browser, if it's not already preloaded, to open the SSF. Press Next. Then you're going to choose whether you're going to use a single or whether you're going to use multiple base providers. Press Next. You'll choose your base provider group. Be sure to select Use Reference Position from base files. And then check the checkbox on Confirm Base Data and Position before processing. This will allow you to check and make sure your base station data has complete coverage for your area. Then you would press Start to activate the tool. Once the differential correction is complete, the next step in the workflow is to export to GIS data. So once you open the Export to GIS Data tool, if the .cor file is not already preloaded, then use the file browser to load the corrected file. Designate the output folder, and be sure to configure the setup properties. If you work in the same area all the time, you can do this once, and then you won't have to do this again. But the properties include information that you can see in the forms on the screen. So there's attributes where you can add GPS fields to the data, and then you want to go in and set your coordinate system and units so that they match your ArcGIS project. Once you press OK to this setup and properties, and then press OK and run the tool, then it will export your GPS data to a GIS data format. Once that tool is complete, it prompts the user to add the exported layer to the ArcMap project table of contents. And you can see in the picture that the large green dots have been added to the project. Now we'll do a PFO tool demonstration. The first thing we're going to do is a quick data dictionary. We'll call this Water Demo. We're going to create a new feature, and we'll make a hydrants layer, and that will be point. We'll choose a color and symbol. Now we're going to add attributes to that hydrant. We're going to create a hydrant ID. We'll have a size field. And we'll make that a menu option. We'll also have another option or attribute called color. We'll make that a menu option also. And finally, let's add a date field so we can know when it was painted. Let's also add valves. That also will be a point feature. We'll make that blue and change the symbol. Now we'll create attributes for the valves. Again, we'll have an ID. And we'll have a pick list for type. Now we have a quick data dictionary that we created to go out and map hydrants and valves. So let's save. Call it Water Demo. Now we're going to transfer that data dictionary that we created to our GPS unit, and we're going to send that information there. So we'll press Add and choose Data Dictionary and select our Water Demo. Now we're going to transfer all, and we're going to move that, and that's successfully been transferred to the GPS unit. Now if we look at the GPS, and select the Data tab, we can now select our Water Demo data dictionary name. And if we create that, we can then see that we now have our hydrants and valves. Now the next step would be to go out in the field and collect the hydrants and valves and do your field data collection. So now you're ready to come back to the office and get that data processed. So the step now would be to open, again, the data transfer tool. This time we're going to receive information from the GPS unit. For the purposes of this demo, I'm going to select information from the unit that has a small size, and we'll transfer that information from the GPS unit to our computer, and that was successfully transferred. Now, the next step in the workflow would be to differentially correct that information. So I have a small file ready to correct for the purposes of this demo. I'm going to use multiple base providers because I've got 2 core stations that I'm going to use for this processing. I've got use reference position from base files selected, and I've got this checkbox to confirm my base data. And I'm going to start the differential correction. My percentage is 100% coverage from the base station data. That's great. So I'm going to confirm and complete the differential correction process. This is a small file, so it'll be complete here in 1 second. Now we can see that this differential correction is complete. We've got good data, It's in the centimeter range for most of it. I'm going to close the differential correction tool. And now the next step in the process is to export that data in from the GPS format into a GIS format. We can see that file's preloaded, and my output folder is where I want it to go. We'll take a quick look here at the properties that I have set up. I want to export all the features. For the attributes, there are GPS fields that can be included in the information. I like to have these included. I've got my units set to how I want those to be, but if those need to be changed, you can press the change button and then go use these drop downs to select what you would like. Also, I have my coordinate system set the way I would like it, but again, you can change and go set that to what you want it to be. And those properties are all the way that I want them to be for this export. So now I can export that information, and I can see that 4 features were exported, and that's how many I had in the file. Now I'm going to add that file to my project, and you can see it's been added here, but let's make that so that you can see it a little better by turning off. And I'll change that symbol to something a little more. Now we can see that my data has been added to the GIS. So we went from the field GPS all the way to the office, so that now we can analyze and use this data within our GIS. And that's all that I have today for the GPS to GIS toolbar that sits within the ArcMap platform. Thanks.